This little mini lecture introduces the projectile motion. And so what you see here is a graph of a projectile, and you can see its location here, 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 etc. Each dot represents motion position of the projectile in increments of 0.322 seconds. So this position right here represents the apex, and here it is coming off the ground, and here it is landing on the ground. It has been launched at 20 meters per second at an angle of 75 degrees with respect to the horizontal, and so something like this. Meters per second, 75 degrees with respect to the horizontal. And you see displacement vectors here connecting the ball positions. And so what I've done here is I've broken each displacement vector, this one for example, into an x component and a y component. And when you look at all the x component vectors for each displacement vector, all during this delta t of 0.322 seconds, you will see that all of these x displacement vectors are equal in length over this equal time period. And so the conclusion is that Vx is equal to a constant. On the other hand, if you look at the y components of these displacement vectors, you can see that they become ever shorter and shorter, the shortest one being just under the apex up to the apex, and then on the way up they become shorter, on the way down they become longer. In fact, you can see this displacement vector and this displacement vector are equal in magnitude in opposite direction, and so is this and this, and so is this and this, this and this, and this and that. And so the y behaves just as if the ball was thrown straight up in the air with an initial velocity equal to the y component of this 20 meters per second angled at 75 degrees. So this is, in other words, it's a vertical motion with a constant a equal to minus g. And so the overall picture that emerges is that projectile motion can be broken up into two 1D motions that are independent of each other. The x direction is constant v, the same x component that it started with, it has the whole time it's in flight, and the y is just as if the ball was thrown straight up in the air with ay equal to minus g and with an initial velocity equal to that.